All right. Good morning or afternoon, depending on what hour it is. This video is to go over the very first section of notes for the second unit of physical science. Um, I am going to assume that you know where your pause button is, and so I'm going to just kind of chug along through stuff. I'm going to have to pause my recording from time to time, but I'm going to assume that you have access to the notes, that you are looking at one of these periodic tables. If you don't have one, the link that brought you here should tell you where to find them. I said notes already, and that you know where the pause button is. So yeah, that should be pretty much it. Let's get going. All right, so we are going to start off on the front page of your Unit 2 notes, where it says, yeah, I'm going to make you write some here. So you need to know that the first guy to ever actually organize the elements on the periodic table, or into a format that later became a periodic table, was Dmitri Mendeleev. And if you don't know how to spell that, I wrote it down here. So pause. All right. So he's the guy who first organized the periodic table. He used atomic mass to do so. So he organized the elements based on what their atomic mass was, and based on some other properties that they had. Uh, and with that information, he was actually able to predict the existence of 3 or 4 elements that had not been discovered yet. And so he was able to describe these elements, talk about what properties they're going to have based on the fact that they were organized in a deliberate manner. So, yeah. Now, since then, we have changed the organization of the periodic table. We do not use the atomic mass to organize the periodic table, the modern day periodic table. We use something called the atomic number instead, which we will talk about shortly. So, yeah, you need to know Mendeleev was the first guy who organized the periodic table, and you need to know what he used to do it. So, yeah. Now that we've done that, let's talk about the things that we do with the periodic table nowadays. So there's 4 main things on the modern day periodic table that you need to be able to recognize just looking at any periodic table. This organization system is constant. Okay? First one are periods. Second one is groups. Third one, cells. This is pretty obvious. The fourth one is families, and we're going to have a whole other video talking about families because families are kind of their own thing. It's going to take an entire class period to really go through the 12 families and how you know where they are. So we will get to them later. We are going to start with periods. So when you look at your periodic table, you will see that there are numbers down the side here. Okay, they start at 1 and they go down to 7. Those are the periods. So, geez, I cannot read my recording. Sodium and magnesium are in the same period. They're both in period 3. Period just means row. It's another word for row. It's a row on the periodic table. Okay, there are 7 periods, which begs the question, where do these go? Because these would be 9. So obviously these are not their own periods. Well, the periodic table is arranged a little weirdly, but these bottom 2 rows are supposed to go here, in this gap here. That's why there's this dotted line at the top and the bottom, because this thing down here goes there. Now, for reference, I'm going to refer to this as the F block from time to time, so you need to know what I mean when I say it. F block is the bottom 2 rows of the periodic table, these 2 right here. Now, these are part of period 6. So, lutetium, is that lutetium? No, that's lanthanum. Lanthanum comes right after barium, and lutetium, down on the other end, comes right before hafnium. Okay. Now, the periodic tables, the large periodic tables in the room, have lutetium and lawrencium in slightly different places. That is a thing that we will talk about in person because that is custom to our periodic table. It's the one problem I have with our periodic table, but we'll get there. Now, for something you'll need to know for future, like next unit, every row represents its own energy level in Bohr diagrams. So that's something we'll talk about more in the future. Now that brings us to our groups. So across the top of the periodic table, there are more numbers, but this goes from 1 all the way up to 18 on the last one. Okay, these numbers are the group numbers. So groups are just numbered columns. So periods are numbered rows, groups are numbered columns. So each group has a certain number of elements in it. Now, the F block, down here on the bottom, the F block, do not have a group because they all go between group 2 and group 3. So nothing down here on the bottom, none of these actually have a group ascribed to them, with 2 exceptions. The last 2 down here, lutetium and lawrencium, they actually belong right here. And they're present in both spots on this periodic table. So these 2 elements are in group 3, but there are a lot of periodic tables that only have them at the end of the F block, and you just have to know that they are part of group 3. So in the F block, lutetium and lawrencium, elements 71 and 103, are part of group 3, not part of the F block, which will make more sense later. Okay. By the way, if you notice I'm leaning off to one side here, it's because on this side of my computer screen, I have the notes pulled up. So to me, I'm only on this side of the screen, and the notes are over here. All right. Now let's talk about the cells on the periodic table. So whenever you have any kind of table at all, and it's made up of rows and columns, every box on that is called a cell. So the periodic table here has 118 cells, one for each of the known elements. Now, it does bear mentioning that we have actually discovered 3 or 4 more elements since this periodic table was designed or made. And we haven't put them on the periodic table yet, and I'm probably not going to add them. I'm just mentioning that now. It's probably not going to come up again this year. So each element has its own cell, and each cell has information for that element. There are 4 things that are found on almost every periodic table. Okay, the atomic number, the average atomic mass, the element symbol, and the element name. Now, Mr. Humphrey and I went out of our ways to find a periodic table that we could hang on the wall that does not have the element name on it. That is so that when we're doing element symbols quizzes, in that last unit that we just finished, we don't have to cover it up and you can still look at it. But this periodic table actually has the names on it. So you can use it to get those names or go back and forth if you're unsure. But if you know them, you can get a lot of stuff done a lot faster. So first off, the atomic number. The atomic number on this periodic table, I'll point at the actual key here, is up in the corner here. Now, it's the blue number on all of the cells. So the atomic number for hydrogen is 1. The atomic number for chromium is 24. The atomic number for oxygen is 8. Okay, that is the atomic number. The atomic number is the number of protons. It is how many protons does this element have. And it is unique for every element. That's why we used it to organize the periodic table. Okay, the defining characteristic of an element is the number of protons. That is how you know that hydrogen is hydrogen. If it has one proton, it is hydrogen. If it has two, it cannot be hydrogen. It has to be helium. Okay, the number of protons is the unique identifier that dictates what element you are talking about. And that is why we call it the atomic number. Because every hydrogen atom, everywhere in the universe, has the exact same number of protons. That is not true for the other subatomic particles. But we'll talk more about that in Unit 3. Okay, the atomic number is the number of protons, and it is unique for every element. And it's the blue number in your periodic table. Okay, second one, the average atomic mass. Now, this is what we call, in modern days, this is what we call the thing that Mendeleev used to organize the periodic table. Okay, he used the atomic mass. Well, now we just call it the average atomic mass now, because we understand what it is a little better. We're not going to go too much into that. You need to know that the average atomic mass is the weighted average of all known isotopes of an element. Yes, I know you don't know what an isotope is yet. That's okay. You don't have to. We'll cover that in the next unit. But you do need to know that the average atomic mass is the weighted average the weighted average of the mass numbers of all known isotopes for a given element. And on your periodic table, it is the red number at the bottom of a cell. Okay, this number down here. Element symbol, we have talked quite a bit about the element symbols already. You've already memorized, hopefully, 30 of them, so you should know quite a bit about them. Okay, it's a 1 or 2 letter abbreviation or representation of an element's name. The first letter must be capitalized. You know who you are. A couple of you still keep messing that up. The first letter must be capitalized. And the second letter has to be lowercase. Again, you know who you are. Okay? Have to capitalize the first letter. You have to lowercase the second letter. There are reasons for that. Reasons that we'll talk about in Unit 4. Okay, but that is so we can tell where one symbol ends and the next symbol begins. I said that in the backwards order, but it works. Okay, the element symbol are the big letters in the middle of the cell. And the last one is the element name. That was pretty self-explanatory. And that is written under the symbols on here. So down at the bottom, right above the average atomic mass, that's where you'll find the element name. And that's pretty much all I've got for this video. So I'm going to pause it here so I can get it uploaded. And yeah, have a good one. Go back and watch parts of this again if you need to when you're trying to figure stuff out. But that's the lecture for Wednesday.